Here's an interesting observation. Well, yes, we can instantiate our objects as normal variables. Yes, we can, let's shut this down. Yes, we can call member functions on these instances that we create. So create point 1, do some work with it. Create point 2, do some work with that particular object. Then even have two objects being involved in, in some work. Like make this member function so it expects another point as a parameter. And we can see that yes, it works. The function seems to be working okay. So then, remember, with integer and other primitive data types, we were able to do something like this. We were able to initialize those guys, okay? So I don't know about you, but I'm completely used to this, and just, resource allocation is initialization. That's the basic principle. So we all have to, assume that when you want to create a variable, it's better that you have the initial value for it, and you just never leave it uninitialized. And it's just a very basic and natural principle. Okay. Given that, how about if I could maybe initialize this to something, right? To make initialization happen, and then maybe I didn't have to call set. Maybe if I could do something like this, right? If I could just do something like this, maybe like that, or actually the syntax is going to look like this without an equal sign. Maybe that would be a better way to create point 1 and point 2, right? So in this case, I will not remove set so far because it demonstrates something, but just saying that this could have been a great way of instantiating a point. Okay, and immediately provide a set of initial values, and immediately put every point that we create, perhaps, into a good state, a known state, and not such state that we had to remember to call set. Otherwise, those x's and y's inside of our points would be just garbage values, as Mike has pointed out earlier on. They were just completely garbage unless we remember to call set. So then the approach is this. To be able to allow this type of initialization, we need to introduce a constructor. I typically, when I type in my code, just like I mark the tail of my class, because especially if I have multiple classes in the same file, it's kind of useful to see this comment. I typically organize my classes by saying constructors, destructors, if there are any. We will talk about destructors definitely next week. But there is this section that I typically create inside my classes where I say, okay, now there goes a set of constructors and a destructor. Okay. If you take the name of your class, like copy, right, and paste it in right here, and then mimic the set of parentheses and say, hey, take this, perhaps I'll use double because we've kind of completely switched to double parameters. I can make a declaration that strangely looks like this. The name of a function, this seems like a function, is the same as the name of the class. In fact, exactly the same as the name of the class. And this is how a compiler will understand that this is a constructor. Set of parameters as in any other member function, right? Just a list of parameters. And no return value. And then also take this and provide an implementation of some sort. And I will keep, placing it right at the top. So strangely, this is going to look like this. Class point has a member function named point, and it's a constructor. And the strangest part of it is that there is no return value at all. There is absolutely none. Not void, not int, not anything else. None. That's the syntax. But the function body is exactly as perhaps we will be expecting, and it probably will be doing the same thing as our set, right? And the alternative to this would be to actually call set. Just say, oh, okay, let's just call set with x, x, and y, y. So those would be two choices, right? But at this point, I'm not doing this because as soon as we introduce member initializer lists, we'll realize that this is something that we probably want more of this, and that's the topic for next week. Okay, today we're not going to get to member initializer lists. We're just going to talk about the purpose of having a constructor. Okay, so once you do this, the purpose of the constructor is to have a function which will be invoked when someone is trying to create our object. Object creation is incredibly important event in the object lifecycle, and typically in a non-trivial application, object creation is one of the biggest challenges. It's like, how do I create all of my objects? And then once they're created, you can just like say, okay, now let them interact. But object creation is absolutely, I mean, it can be actually very challenging to configure all of your objects. And you have to make a decision which one I create first, because they may be somehow interdependent, and object creation is very, very important. From this standpoint, object-oriented languages provide you a way to create a constructor, which will then, you should be able to use just like this. You should be able to create your variables and immediately pass whatever parameters you think are good choices to create your object. So let me save everything and try to compile it. I'm predicting that this will not compile, but we'll try anyway. Right? So strangely now, what is happening here is that you get this error, you double click on it, it points to this line, and what it complains about, it says cannot access a private member declared in class point, and that is the name of our constructor. Well, of course, because you have to declare your constructors public. Okay, so that was the reason for that error, right? So if by mistake I made my constructor private, effectively I am disabling creation of my object. It's suddenly people have trouble creating my objects. This kind of design pattern, if you will, has a place. It can be used, because then what can be done is that a static member function could be given to the point, which, remember, can have access to anything, including private constructor, and still can be used to call and instantiate a point. But that's not part of discussion today. Well, anyway, typically normal constructors are declared public, just as this one. And this time, if I try to build this, I'm just hoping that it's going to be built properly. And so now the calls to the set member functions are redundant. We probably don't need that. Well, at some point later on, I want to update the coordinates of my points, much later on perhaps, and that's okay. That's normal, right? So I can update the positions of my points and change it to something else, whatever that is, right? So I can make those updates and make those changes later on, and like someplace over here. So I reposition my points before I make another computation of a distance. In fact, let's build this right real quick, and so now with this change, Control F5, run it, and there you go. So we've got different distances because we now are capable of move them around. But initially we found a way to introduce a constructor member function, which actually is invoked when you pass these parameters.